This is so from today we are starting with the new chapter for 10th class, that is similarity, right? So children, before I will start with the theorems, let us recap what else we know about similarity. See, similarity means what? I have a small circle which is similar to a bigger circle. I have a small triangle which is similar to a bigger triangle. I have a small square which is similar to a bigger square. That is called your similarity. Children, in your 9th class, 9th standard, you might have gone through congruency. Congruency. Now, congruency, or two triangles are congruent. Suppose if I am telling you that this triangle, if I am saying that this triangle is congruent to this triangle. Suppose this is your triangle ABC, this is your triangle DEF. If I am telling that these two triangles are congruent, see, similarity sign is like this, congruency sign, two lines and arrow like this. Now what does congruency means? If I am telling this triangle ABC is congruent to triangle DEF, what does it mean? What does it mean? It means this side is equal to this side, this side is equal to this side, this side is equal to this side, this angle is equal to this angle, this angle is equal to this angle, or this angle is equal to this angle. What does it mean? That if I am telling you the two triangles are congruent, it means all the sides of one triangle are equal to the corresponding sides of another triangle. If all the angles of one triangle and all the angle of one triangle are equal to corresponding triangle angle of the other triangle. Okay children? Though in your 9th standard you might have gone through, there are different criteria for congruency: SSS, SSS, SAS, ASA, RHS. So you should recap this concept also, as while studying this similarity in triangles, sometimes we have to use these results: side congruency, side congruency, angle side angle congruency, and right hand side congruency. We have to use congruency while solving some of the problems of similarity, right children? So let us start with the first theorem, that is, this is called basic proportionality theorem. We call it also Thales theorem, children, right? Now, see, he is saying here that if a line is drawn to one side of a triangle, see, I have a triangle like this. This is the triangle. Children, this is a triangle, and triangle is ABC. Now he is saying here, if a line is drawn to one side of if a line is drawn parallel, the term should be parallel, okay, to one side of a triangle. So here I am taking a line, let this line is DE, and it is parallel to other side, right, to one side of a triangle to intersect the other two sides in distinct points. So those distinct points are D and E. Then the other two sides are divided in the same ratio. This is the basic proportionality theorem. Let us understand it, what he is going to ask you. Children, before reading this statement, let us see what is given in this theorem. So in this theorem, what is given? The first thing which is given to you, in triangle ABC, I have given that DE is parallel to BC. This is given, children. DE is parallel to BC. Okay, line is drawn parallel. Okay, now what we have to prove? We have to prove that it divide the other two sides in the same ratio. That is why this is proportionality theorem. What does it mean? He is telling that we have to prove that AD over DB is equal to AE over EC. So this is the thing we have to prove, and this is the thing which is given to us. So this thing should be clear before we proceed, children, right? Now before we start proving it, we have to do some construction here. So let me do some construction to prove this theorem. So what are those constructions? See, first construction which I can do is this one, that I join this B with E and draw a perpendicular. This is EN, right? So what is first construction which I am drawing here? That join B and E and draw NE perpendicular NE or EN perpendicular AB or AD, right? Here I can say draw and draw. Okay, children, and draw. Okay, children. So this is one. First. Second, before I will write the second thing, let us start to see what we can do here. Children, here we can do one thing. What is that? Okay, let us see what we can do here. Here, now, I'm starting with the proof part of this theorem. This is the proof. Okay. So what is the proof? Let us start with. Children, here I am writing that area of triangle. I am taking the triangle ADE over area of the triangle DBE, triangle DBE. So you know, children, in a right angle triangle, the formula for area is half into base. Here base I am taking AD, and here height, children, height to this triangle is NE or EN, you can write. Okay, children. Now here in this triangle DBE, here base is half, base here in this case is DB, and height is same, NE. Okay, children. Many children can ask that, sir, how can we take perpendicular this? See, children, if I have a triangle like this, I am taking it as a base. I can proceed it further. I can take this height, you know, the area of this triangle is nothing, half into this B into H. This thing should be clear in your mind. If you are taking this triangle, I am taking the height, that one, that this is NE. You understand it? That's why I have taken it like this. I think you have understood it. Okay, children. So now I'm starting with this part. So now, here in this case, half cancel out with half, any same. So we are getting here AD over DB. Let it be number 1, children. This is number 1 result. So we have proved one thing, that area of triangle ADE over area of triangle DBE. This is first result for basic proportionality theorem. Have you understood, children? Okay. Now I am doing here second construction. So what is that second construction here? In the second construction, I am drawing a perpendicular from here like this. Let this perpendicular is DM, and here I am joining D and C. So what is your second construction here to prove this theorem? That join D and C, and draw DM perpendicular AC. Right? Now here I am taking again what? This triangle, area of triangle ADE over area of triangle. I am taking now the triangle DEC. Here I am taking the triangle DEC. So this is DEC triangle. I am taking it from that side, children. So here I am taking the base as half. Base in this case is AE. Height in this case is DM. And here half. Here I am taking this triangle. So here base is EC. Height remain the same, DM. This thing you have to understand, children. So this cancel out, and we get here area of triangle ADE over area of triangle DEC is nothing but AE over EC. Let it be number 2, children. Right? I hope you have understood these two results here. Now one more result. Children, if you recall your 9th class, suppose I have two parallel lines like this. Like this is one parallel line and this is another parallel line. I have two triangles like this. See, I have this is ABC and this is DBC. This line is parallel to this one. So what is the concept that you might have learned in your 9th standard? That area of two triangles, this is very important, understand it. Area of two triangles with same base and between same parallels, same base and same parallels are equal. That's very important, children. So if you try to understand, see this line is parallel to this one. So area of this triangle, let me shade it like this. Area of this triangle as well as area of this one triangle, children. Let me shade it with this dark line, this one, that is equal owing to this result. Okay, so what does it mean? That area of triangle, which one? DEC and which one? DBE is equal to area of triangle DEC. Now children, from 1 and 2, you just watch it clearly. It is quite clear from 1 and 2. This is your first result, this is your second result. See, this is equal to this. They are equal, and this is equal to this from this result. So therefore, from here, what we can say? So we have proved this result What is this result? So we have proved this result that AD over DB is equal to AE over EC. You can say here from 1 and 2. So we have proved this result. Children, sometimes in this theorem it is not asked, but sometimes you can prove another result. You just take reciprocal of this. Take reciprocal of this. This is dB over AD equals EC over AE. And just add 1 both sides. So just add 1 both sides. EC AE plus 1. If you just simplify it further, you will get another interesting result, children. What is that interesting result? Here you get dB plus AD over AD, and here you get EC plus AE over AE. If you simplify it further, see AD plus DB. AD plus DB is nothing, AB. AB over AD equals AE plus EC, nothing, AC over AE. So sometime examiner may ask you to prove this, or you can take the reciprocal of this result. Sometime he can ask you prove AD over AB is equal to AE over AC. Children, examiner can ask this result in many ways, but this is your basic proportionality theorem. Very easy. If a line is drawn parallel to one side and cut the other two sides at distinct point, then these two ratios, AD over DB is equal to AE over EC, that we have to prove. This is your basic proportionality theorem, children. I hope you have understood it, enjoyed it. Okay. So children, let us start with the converse of this basic proportionality theorem. In the converse, what he is saying, if a line divide any two sides of a triangle in the same ratio, then the line is parallel to third side. We have proved the basic proportionality theorem. It is just reverse of that, converse of basic proportionality theorem. So children, let us start with the proof part of this theorem. Okay, so how to prove it? Here he is saying that suppose we have a triangle like this. This is your triangle ABC. This is your triangle ABC. Now here in this triangle, he is telling you if a line divide any in this, so you have a line. It is not given this is parallel, we have to prove it. You have a line DE. So what is given here? Let me write the given part. So what is given here? Given is a line DE, a line DE divide AB and AC such that you have given AD over DB is equal to AE over EC. This is given, children. This is given to you, right? This part is given to you. We have to prove. So what is the proof part here? To prove, we have to prove, what we have to prove? That this DE, this line DE is parallel to BC. This part we have to prove. Okay, children? Now, to prove this part, let us prove this result by contradiction, children. What is contradiction? Let us start. Suppose we are telling here, suppose this we take a line we take a point, children, we take a point. What point? Here we are taking a point E dash on AC such that D E dash is parallel to BC. Let me tell you what I'm contradicting here. We are saying that this DE is not parallel to BC. So we are taking another point here. Let that point be E dash, right? And now if this, you consider this line, see this line, this is parallel to BC. So in contradiction, we are saying that so DE is not parallel to BC. So we take another point on AC such that this DE dash is parallel to BC. This is the construction, not the proof. We can say we are doing some construction to prove this result. So now I'm starting with the proof part, children. Let us start with the proof part. Okay. Every step you have to understand carefully. Examiner give the marks accordingly. Okay. Let us see. Here now, if I am taking this triangle ABC. Now in this triangle, this DE dash is parallel to BC. From where we have taken this result? From construction, children. We have right now done the construction. So you must mention it there actually that we have taken this result from the construction. So now if it is like this, what does it mean? It means AD over DB must be equal to AE dash over E dash C. So this result I have taken from where? From where? BPT. BPT means basic proportionality theorem. You must mention it there. You know that in previous theorem we have gone through, if this line is parallel to this, then this upon this is equal to this upon this. We have written it. But children, it's given over here AD over DB is equal to AE dash over E dash C. See, this part is given here. You check it. This part is given. From where? You must mention it. This is given. Let it be number 1 and let it be number 2. So, see, these two are equal. So, these two must be equal. So, I am writing here from 1 and 2. So, I am getting this result. AE dash over E dash C is equal to AE dash. Here we are getting what I have written here, AE dash. No, this is not given here. It is given AE over EC. This is given. Okay. Actually, what is given here? AD over DB is equal to AE over EC. Sorry, I have written wrong here. Now I have corrected it. You just understand it. So from where we get AE over EC from 1 and 2. Okay. You just do the reciprocal of these two terms like this. E dash C over AE dash is equal to EC over AE like this. Now you add 1 both sides. Add 1 both sides. Let us add 1 both sides. We get here E dash C over AE dash plus 1 is equal to EC over AE plus 1. Right, children? If you simplify these two further, you get here, I'm writing it here, AE dash, and here you get E dash C plus AE dash is equal to here AE, and here we get EC plus AE. Right, children? I have taken the LCM and we get this result. Okay, understood? Now you see E dash C plus AE. E dash C plus AE dash is nothing. You get here AC over AE dash. And here EC plus AE. EC plus AE is also AC. So you get here AC over AE. So AC cancel out with AC. We get AE dash is equal to AE. Now look at children. What he is telling here now in this case, that here we have proved that AE dash and AE, they are equal. Now, so we have contradicted our statement. You can say here, it is not possible. I am writing it with the red pen so that to understand it. It is not possible unless what? E and E dash coincides. Okay. So if these 2 points coincides and you are telling that this DE dash is parallel to BC in your construction part, therefore DE is parallel to BC, right? We have proved this result by what? By what concept? Through contradiction. So basically we have proved that E and E dash coincide. So if DE dash is parallel to BC, then DE must be parallel to BC. So this is the proof of the theorem by contradiction. So I hope children you have understood these two theorems clearly. Okay. So children, keep on watching my channel. We have gone through basic proportionality theorem and its converse. In the next video, we will go through some of the questions related to this topic from NCERT exercise. Children, this channel is devoted to all those children who want to study mathematics in an easiest way. So just try to start your mathematics journey with me. I am fully confident if you follow me, you will understand this beautiful subject in a beautiful and easiest way. Try to share this video with other children also. Subscribe my channel, press this like button also, so that I get inspired and I can help you in all best possible ways. Okay children, thank you.